Hello and welcome to another episode of the Williams Learning Lab. In this episode we are going to discuss how to balance a combustion reaction. And the generic formula of a combustion reaction is we'll have a hydrocarbon of a certain number of carbons and hydrogens, and that will be reacted with oxygen, and that will yield carbon dioxide and water. In this example, we're going to balance the equation of propane being combusted into carbon dioxide and water. Sometimes oxidation reactions such as combustion can get a little bit complicated, so there's a couple of tricks. Well, primarily, try to balance your carbons first. After you balance your carbons, then balance your hydrogens, and then save oxygen for last. All right. What I like to do is I list each element on both sides of the reaction arrow. Have carbon, hydrogen, oxygen, and on this side I have carbon, hydrogen, and oxygen. Just going to draw a line. Okay, first let's count them. We have 3 carbons. We have 8 hydrogens. We have 2 oxygens. On the product side of the reaction, we have 1 carbon. We have 2 hydrogens. Now be careful, we have 2 oxygens in the CO2 and then 1 oxygen in the H2O. Don't forget to count both of them. Okay, so we can see they're all unbalanced. The 3, 1, 8, 2, 2, and 1. So each of the elements are unbalanced. So let's see what we can do. Well, our little trick that I introduced is let's balance the carbons first. All right. So we have 3 carbons on the reactant side. We have 1 on this side. What number can we multiply times 1 to get 3? Well, that's 3. So let's put a coefficient of 3 right here. And let's see what the consequences of that are. So 3 times 1 carbon is 3. And that also affects the oxygen. So we have 3 times 2 oxygens, which gives us 6. Plus we have 1 more right here. And so that gives us a total of 7. And we still have 2 hydrogens right here. So it looks like our carbons are balanced, but our hydrogens and our oxygens are still out of balance. And it's starting to look a little weird. Look, we're getting odd numbers, but don't fret. So now we have 3, 2, 7 and 3, 8, 2. Well, the trick was let's balance the hydrogens next. Okay, so we have 8 over here and 2 over here. Well, what number can I multiply times 2 to get 8? Well, that number is 4. So let's put a coefficient of 4 right here in front of our H2O. And let's see what those consequences are. 4 times 2 is going to give us 8. And 4 times 1 oxygen gives us 4 plus our 6 that were over here. So 4 plus 6 gives us 10. All right, just say it again. 4 times 1 oxygen, 4. Then we have to add the other oxygens over here. 3 times 2 oxygens is 6. 4 plus 6 gives us 10. All right, so we still have 3 carbons on this side. And we still have 3, 8, and 2. So our carbons and hydrogens are balanced. Now we just have to get our oxygens balanced. Now this seems a little bit more doable. So what number can we multiply times 2 to get 10? That'd be 5. So we'll put our 5 right here, and let's see what the consequences are. 5 times 2 gives us 10, and we still have 3 carbons, and we have 8 hydrogens. Okay, so it looked complicated, but it turned out to not be so bad. We have 3 carbons on both sides, 8 hydrogens on both sides, 10 oxygens on both sides. If you found this video valuable, would you consider commenting, or subscribing? And until next time, keep on learning.